Hey, what's up, guys? In this video, I'm going to show you how to make a hose adapter. Let's say you have a 2-inch hose that you need to get to a 1-inch hose or a 3-inch to a 2-inch. I think a common case for this would be like a vacuum hose adapter. In my case, I want to adapt a 50 millimeter scat hose to a 35 millimeter scat hose for the heat duct in my aircraft. But I think the common use case is probably a vacuum hose adapter. If you've ever wondered how to make your own hose adapter, which is a really common use case for 3D printing, I'm going to show you exactly how to do it. I hope everybody has their tasty beverage. Let's get started. Okay, if you haven't seen my other video about instrument panel labels, I have a small section on a crash course for how to use Fusion, Autodesk Fusion. If you're unfamiliar, if you have never before used Autodesk Fusion, you should definitely watch that section because I walk you through all the basics that I'm going to go through here today. Okay. Now, once you've watched that section, or if you're already familiar with CAD software in general, let's dive in together and let's get this hose adapter created. Quick and dirty style. Okay, so what we have here is Autodesk Fusion. If you've never used Autodesk Fusion before, it's free for non-commercial use. They have a little bit of a restriction where you can only have 10 editable files open at any given time. Basically, that means when you go into your file directory, you just set all of your previous files to non-editable and you can just create new files. Kind of an arbitrary limitation, but thank you so much to Autodesk, I guess, for giving us this software for free. I am in no way affiliated with Autodesk. I just like free CAD software. Okay, so the tool that we're going to make use of for this part, which is basically like a 2-inch to 1-inch hose adapter, is this Revolve tool here. Okay, now imagine if your adapter was in the vertical dimension. If you slice down vertically your adapter, what the outline of the actual interface would look like, that is what we are going to draw. Then we're just going to revolve that around in a circle because it's axisymmetric. Okay. I just learned that word today. Axisymmetric. Pretty dope. Okay. So we're going to start with a new sketch. I'm going to go over here, click create sketch. And then I'm going to make it on the XY plane. Okay. I'm going to click that. And then, of course, it moves our view around. So now we're in the sketch because we see the finished sketch check mark over here. Okay, so I think what I'd like to do is go ahead and create the axis of rotation. So I'm going to click line and then go to line type, and I'm going to change that to construction. Maybe it shouldn't be construction. Let's just create a normal line here. Okay. I'm gonna orient it off of origin. So I'm gonna let my cursor snap over the origin here. And then I'm just gonna come up some arbitrary amount of dimensions. Okay, and then hit plus or check mark. All right, I'm gonna hit escape to exit the tool. The middle mouse button will pan the zoom around, the view around, okay? So now that we've created a line, we need to dimension this. This is just going to be our axis of rotation. So in my case, this is my adapter, okay? This adapts 50 millimeter hose to a 35 millimeter hose. I need to know what the length is, and I'm going to make that length slightly longer in order to create my axis of rotation here, okay? So I'm going to take my calipers, and I'm going to simply measure the length. Okay, I've got about 50 millimeters. Okay, so I'm going to hit D, or you could click up here in Sketch Dimension, click the line, drag it out, and then do 50 millimeters. Okay, now the line starts on origin and moves up, but what I think I'd like to do is have this line centered on origin, just because that's, I think, how I'd like to align it. So underneath the constraints toolbox here, there is a constraint that says midpoint. So if I click midpoint, I click the line, and then I click origin, it doesn't work. Let me try, I'll click the line, click midpoint, and click the origin. Still doesn't work. Okay, what's going on here? Okay, let's try this again. Let's delete the line. I think what's happening is we had a constraint that put the end of the line at the origin. So let's create a new line that is not constrained to the origin. So I'm going to click plus or check mark there. And then let's dimension this line. We made it 50 millimeters. Okay. But see, it's not a dark black. It's this blue color. That means it's not fully constrained yet. And just constrained means that every dimension is accounted for. Okay. So I'm going to click the line. I'm going to click midpoint, and then I'm going to click the origin. There we go. Now it's fully constrained. See how it turned from blue to black? And then we have this little constraint listed here. You can use the mouse wheel to scroll in. Okay, perfect. Now imagine this is the very center of the adapter, okay? Now what we need to do is draw the outline of the adapter and then rotate the outline of the adapter 360 degrees, okay? So there's two dimensions that I'll need here. I'll need the small dimension. So I'm going to measure this. Let me make sure that I'm zeroed out. I'm going to measure the small dimension at 37.5 millimeters. Okay, so let's draw half of that. So I'm going to hit line. I'm going to start from the top here. I'm going to come out half of 37.5 millimeters. Okay, so I'm going to hit dimension or D. I'm going to click this and do 37.5 divided by millimeters divided by 2. Okay, so that it does the math for us. Perfect. 18.75. Okay, now remember, this is getting revoluted, so this will be the radius, not the diameter that we just measured. Okay, then now I need to measure the large dimension. Okay, that is 50 millimeters. So let's go ahead and so I'm going to click line. I'm going to snap to the bottom part here. I'm going to come out and go check mark. Okay, hit D, dimension this line, and then we'll do half of 50 millimeters. So 50 millimeters divided by 2. See how you can do math inside of this dialog box? Very convenient. Okay, so that's 25 millimeters. Okay, so like let's now imagine that we just drew a line between these two dimensions. We'll go ahead and do that, and then I'll hit finish sketch, and then let's demonstrate the Revolute tool. Okay, so I'm going to click Revolve. I'll click my area. So the first thing that it wants is the profile. Okay, so let's select our area as the profile, and then the axis will be the axis on the x-axis, okay? So once I select that and I sort of pan around, see how we've sort of made this shape just by spinning around the x, is that x-axis? The y-axis, the y-axis. So I'm looking over here, see the y comes up out out of the like it goes towards the top, essentially. Okay. So let's hit cancel. Let's go back to our sketch. So there's a couple things we desire here, right? We would like for there to be a straight section so that we could attach the hose to, then a sharp interface, and then another straight section, right? Okay. But let's not forget that we also need a hollow inside. So we can't just make a solid surface. We need to make a thin sort of perimeter that gets revolved around. So let's work on that. Okay. So let's delete this line out here. I'm gonna click this sort of angled line and hit delete. So ideally, I'm gonna select line, and we're gonna have a line that goes straight for 18.75 millimeter radius down to the center point, right? Let's say it's somewhere here, okay? And then I'll create another line, and it'll go straight down to the center point. Say it's somewhere around here as well, okay? Hit plus or hit check mark. And then if we just wanted to close the surface, we could connect these two lines together, right? That's not very uh, nice, If we tried to print this, um, obviously we would try to print it either straight up, right, or straight down. We don't want to print a curved surface on the side, right? And the problem with having a 90 degree is that 3D printers can't print in the middle of space, right? Like it can't just print, 30 millimeters up without any type of support. So we'd like to make this section sort of like curved in. We want to smooth it out. In addition, the airflow on the inside is going to like it a lot more if this area is smoothed out as well, right? So let's undo a couple here. So I'm going to undo the sidelines here. And then I'm going to use some construction lines to identify exactly where I want the transitions to start. Okay. So I'm going to come here. I'm going to create a horizontal line, construction line, out to somewhere. Hit go. Okay. I'm going to do the same thing again. Hit check mark. Now let's dimension exactly where we want the transitions from straight section to angled section to happen. Okay. So I'm going to hit D for dimension, hit the construction line, come down to origin. So what would be a good length to smooth out two straight sections into each other? Okay. So this is where I like to use the caliper. And then I'll just kind of open it up and say, well, let's see, this much looks good. Just smooth it out. That's about 4 millimeters, let's say. Let's say it's 5 millimeters, okay? So I'm going to say 5 millimeters, and then I'm just going to do the same thing here. Construction line to origin, 5 millimeters, okay? Now let's run the straight section down to the transition line, okay? So I'm going to I'm going to hit line. I'm going to let the cursor snap over the edge of this, the profile that we've set, and I'm just going to come straight down to the transition. But I made a mistake. See how this is a construction line? This is going to be a line that we use to create the edge. So let's select the edge and then unselect line type. Okay, let's create another line, unselect construction, and then we'll do the same thing for the other side. Okay, so now we have two straight sections that match the radius that we need for the hose. We just need to create a little transition. Okay, so my first thought is to just hit line and then sort of draw a straight line between the two to create a little like angled transition. I mean, this looks pretty good to me, right? Like you can imagine the hose slipping over this, and then the hose will kind of stop where it gets too big, and then a hose clamp will go over that, right? Let me show you. Here's a hose. Here's the hose clamp, and then here's the small section, right? Like there's only so far it can go when the radius gets too large for the hose, right? But on the other side, if we tried to slip a hose over this, it could maybe go too far. Also, an exact angle is not the best thing to print. It's also not the best for airflow if we're thinking about the inside of this. So let's go ahead and create the thin outer surface, because if we revoluted this, let's go ahead and finish sketch. We'll do a revolve. We'll select this. No, it wants the axis. So I want to select the y axis. See how it's a solid part all the way through? We don't want that. We want the outside to be thin, right? So let's go back to the sketch. Now, an easy way to do this would be to select all the outside lines, okay, and then click offset. Okay. So this little arrow will let us draw a little offset line to however thick that we want the outside to be, right? So let's make it 2 millimeters. Now see what it did? It actually sent it in the other direction. So I'm gonna hit Control Z. I'm gonna do it again. I'm gonna select the outside lines. Hold Shift to select multiple lines. Okay, so we've selected the 3 lines, but not the rest of the sketch. I'm gonna hit Offset, and then we're gonna do -2 millimeters. Okay, that looks like a good thickness to me. So you can see when I hover over this little surface area, this seems like more a thing that we would want to revolve, right? Not a solid body, not the full thing all the way to the axis. Okay, so this looks pretty good to me. But now that I think about it, I kind of like to smooth this out. And the smoothness of the interior probably needs to match the smoothness of the exterior, just how I'm thinking about it. So I'm going to hit Control Z, and I'm going to go ahead and fillet the transition zone. So I'm going to come up here to the tool that says fillet, and I want to select this corner and this corner and give it a nice, big, smooth transition. So maybe 8 millimeters looks pretty good to me. Okay, so we got a nice smooth transition. So now I think that's a pretty good line to offset. So I'm holding down Shift. I'm going to select each individual line of this right-hand side here. Okay, see how so it's all dark blue. Then I'll hit Offset, and then we'll offset. Remember, it's going in the wrong direction, so we'll do -2 millimeters. I think that looks a lot better. That's a lot smoother, right? Now I think this would be reasonable to revolve. Okay, so exit it out of my sketch. I'm going to hit the Revolve tool. The profile is just the outer edge here, and then the axis, we want to select the whole y-axis here, okay? So I think this looks pretty good. Look how smooth it is on the inside there. I don't think airflow will have a problem with that. The only thing I'm seeing here is if we go to add the large diameter hose to the outside of this, we're going to see the hose has the ability to go past the transition point. And I think it would be nice to have a little bump to prevent the hose from going too far on the large diameter size of this. So let's hit cancel. Let's go back to our sketch. Oh, it put me in a weird, I'm gonna click front in the view cube up here in the upper right and click front again, okay. And I think on the outside here, I'd like to put a little circle bump to prevent the hose from going too far. Okay, so I'm gonna click center diameter circle. I think I'll center that on the transition and then maybe let's do it as large as the transition starts. Okay, I think that's okay. Now, the problem we're going to have here is we want to be able to select, let's see, this outer circle edge, and then also the outer edge here as well, the thin outer edge but we don't want this little like hump on the inside, so we want to cut the circle away. We want to cut away the parts that don't matter. Okay, so we're going to come to trim, and then when you hover the trim tool over a section that can be deleted, it'll turn red. So yeah, I think I'd like to delete this part, and this part, okay? And maybe even this part and this part. There we go. So now if I hit escape and I hover over this, it highlights the entire outer edge that we'd like to revolute. Well, there we go. See how good that looks? Perfect. The other thing I'd like to do is that's kind of a sharp edge for a 3D print to create. So let's fillet these sharp edges. So I'm going to hit fillet. I'm going to click this one and that one, and then we'll give it something pretty large. Yeah, say 3 looks pretty good. Finish sketch. Beautiful. Okay, so one final time, let's hit our Revolute tool. Let's select the outer edge. Let's select the axis. Click the little axis uh, box over here, and then select our Y axis, and it should revolute around. Look how good that looks. Okay, so for the smaller tube, it'll stop when the radius gets large, it starts to fan out. And for the larger tube, it'll stop when it hits this little uh, bump out that we created. That looks pretty good to me. Now we could come in and we could do some fillets around the far edges here. This will be inside the tube, so it might be nice to have the airflow not tripped up. But thinking about it, one of these sides is going to be down on the edge of the build plate. And so filleting it will probably not come out with the greatest surface texture. So it might be rough anyway. I think I'm going to leave it as is. I'm going to hit OK. And that's it. We've got our part created. We've in my case, we've gone from 50 millimeters to 35 millimeters or so. But in your case, you might go from 1 inch to 2 inches, 1.5 inches to 2 inches. There's a lot of different vacuum hose widths. But if you have a 3D printer, all it takes is 10 minutes in Fusion to create a part like this. Okay. So now what I have to do is export to our 3D print slicer. What we're going to do is hit Utilities, and then over here on the left-hand side where it says 3D print, looks like a little 3D printer. We're going to click that. Then the object to export is we only have one object in this design. Just going to select the one body. Format's 3DF, that's good, and hit OK. Okay, so I'm just going to name it hose adapter. Okay, we're going to go to 3D prints on my local directory. Perfect. So we'll do 3D prints. And then I'm just going to 3MF automatically opens in Bamboo Studio. So I'm going to go ahead and double click that. Oh, got a new version. I'll update that later. Okay, so we see that it's sort of imported on its side. I need to either print it this side down or this side down. So I am going to rotate it, 90 degrees? So I'm going to select the object, click the rotate button. Looks like red might work. So I'm going to do, let's say 90 degrees. Sweet. Sweet, sweet, sweet. That works. And then in my case, I would like to print it in, this is a test piece. So I'm going to print it in PLA black. So I'm going to select the object and hit 3. And the reason why I can color it that way is because over here on the left-hand side where it says project filaments, the filament that I have loaded that's black is currently numbered 3. So you can just select an object, hit that number, and that's what it colors. Okay. Now the only other thing for a part like this is we probably want to print it with 100% infill. So I have the standard profile for 0.6 nozzle. That means it's a 0.6 millimeter hole nozzle. You could go smaller, layer height, but I think for this part, probably wouldn't matter a whole lot. But one thing that does matter is that we want it to be 100% infill. So I'm going to come over here to strength. Let me move my face. And I'm going to change infill density to 100. And then it gives me a little warning about something that doesn't matter. Okay, and hit OK. Perfect. So that's it. We're done. I've got the right printer selected. I've got the right build plate selected. I have the filaments selected. The diameter of the nozzle is correct. So all I have to do is hit slice plate. Okay, it's only a 23-minute print. So let's go ahead and hit print plate, and then we'll hit go, and we'll check back in a few minutes and see how it went for us. Okay, so here's how our hose adapter came out. Boy, this is just an absolutely beautiful print, man. It's crazy what 3D printers can do. You know what I'm saying? So here's one side of my original hose in the print, and it just slips on there beautifully, man. I even cranked down the hose clamp and holds on there nice and tight, no problems. Now, the thing you should be doing is printing your test pieces in PLA. It's cheap, it's easy to print, you can get your dimensions approximately correct, and then you want to print the real part in an actual engineering filament if your environment demands it. Okay. For something like a vacuum hose adapter, PLA is perfectly fine. The problem you might run into with PLA is if you let it sit out in a hot garage, it could potentially warp on you. It could PLA also has a tendency to sort of like if you apply load to it, it'll slowly start to bend over time. Not great. I think for something like a hose adapter where it's equally compressed on all sides, it probably won't move on you and you'll probably be okay. Uh, but just keep that in mind. You could easily step up to something like PETG or ABS. In my case, the air coming off of my exhaust is what's going through this. Okay, so I think this is actually a pretty decent temperature. I haven't measured it exactly, but I have selected nylon, specifically PA6, glass-filled nylon, and I'm going to give that a print and report back to you guys. But all I'm saying is you need to pick the right plastic for the part that you're going for, right? If it's just an average everyday print, lives in your house, PLA, perfect. But you have to pay attention to what temperature and what the operational characteristics are going to be. Okay. I hope this has been good for you guys. If you have gotten some type of value out of this content, please give me a like and subscribe, or send me a message down below telling me that you made some parts out of this. I'll see you guys on the next one. Cheers.